Okay, welcome back, everybody. It's 2:30 p.m. IST, so we're getting back into it with our session 3. I invite Professor Peter Murray-Rust to speak on evaluating scientific work beyond traditional publication metrics. Dr. Peter Murray-Rust is a distinguished professor of chemistry at the University of Cambridge. He is also a co-founder of Semantic Climate. He is a pioneer in text mining through the Content Mine, an advocacy and implementation project consisting of a community, framework, and toolset. He is currently developing the library to support downloading and analysis of documents, mainly from open access repositories, from published scholarly articles, or from authoritative sites such as UN IPCC or UNFCCC. Professor Peter, it's great to have you here. You may begin your presentation now. I'll stop sharing my screen here and I'll make you
Right.
a presenter.
Okay, you make me presenter.
There you go. You should be able to share your screen now by clicking on the share button.
At the moment or not?
Not right now.
Okay, this is okay. If I go to share, can you? Okay. Let's say entire screen and see what happens. Allow screen. Oh my God. Select a tab to share coordination. I want to share in right back. What do I have to open something here? Cisco WebEx meetings. Let's try that. This is the problem. Use password. What the hell do I have to do here? Look, I don't seem to be able to share my screen. Permission to share content. This is the problem with having umpteen different.
Dr. Peter, if you're unable to share your screen, you can just send me the presentation and I'll share it for you here.
Well,
So
we
you
can
can send it to Dr. Renu.
See, this is the. We should have done this in the breakfast time, right? That's what I wanted to do.
Dr. Peter, can you share the presentation to Dr. Renu so we can have it here to our end?
How do I share it?
You can just email it to her.
Okay, I'll email it to her. Oh dear, it says it's going to be sent as a Google Link drive.
You can also send it on Slack if you want. I think that might be convenient.
I think Slack. This is actually part of what so I'll talk while I'm doing this. You might have something here. This is because there are umpteen different platforms and they're all incompatible. And that's the problem that we have at the moment. We have people who are okay, so I'll upload my presentation here to Slack. So we've got Slack, we've got WebEx, we've got Google, we've got PowerPoint, we've got umpteen different things, all run by companies and all who think they're the center of the universe. And that's the problem that we have when we try and do something which is run by corporations rather than run by the community. So, Renaud, can you see that on Slack? So while we're doing this, I'm going to do a phytochemical experiment. And the problem we face is that there is no unified standard for talking on the internet. There are about 6 different companies, all of whom are competing, all of whom who think they own the web. And that is what Cory Doctorow calls enshittification. It's taking something which was straightforward and where every single commercial player has their own approach to it. So this has happened in molecular science. It's what I'm going to talk about when we get the slides up, and where the whole process has massive friction. By the way, can you hear me and see me?
Yes, Dr. Peter.
You
Just
can.
give us a
Okay.
moment and we'll get the
That's all
presentation
right.
up.
Well, I will tell you what I'm doing. I am doing a phytochemical experiment. Can you see that?
Yes.
Can people see that? Right? That is blue tea, and blue tea is the standard drink of semantic climate. On the left, on one side is dark tea, which is from Clitoria ternatia, called blue butterfly pea, and we have that. The other one on the other side, I think you can see, is much less blue, and that's from convolvulus something or other whose name I forget, but both of those are called this. Can you see that? I got this yesterday, Shank Pushpe flower herbal tea. It is actually from India, and that's what I've used to make this other one here. Now, this one, both of these are acid sensitive, so I'm going to do an experiment now, and I'm going to add lemon juice. Can you see the lemon juice here? And when I add that, can you see it's changed color? Can everyone see that? Somebody say yes, otherwise I'm talking to
Yes.
nobody.
Yes, Dr.
Right.
Peter. We can see
Has
it.
it changed color?
Absolutely.
Good. Okay. That is a phytochemical experiment, and I will show you when we come to it in our slides. Are we close to being able to show the slides?
You should be able to see them now. Are they visible?
What am I looking at? at the WebEx.
Can
Am
you
I in the
see
WebEx?
my screen? Yeah, on the WebEx.
I can't see anything on WebEx. Okay. Am I on WebEx now? Right.
Yes.
Okay. These slides. Can you see my first slide on this?
Can people in the chat please confirm whether they can see the slides or not?
Yeah, they can.
Can you see one
Okay.
which is called Semantic Climate and Codata OT Virari?
Yeah. That's the one.
Good. Okay. Right. Okay. So, and let's see if I can change slides on this.
I'll be changing them for you here
Oh,
because
you'll
I'm
be
the one.
changing them. Fine. Okay.
Yeah. You can just tell
Next.
me when to move.
Okay. So this is a particularly good example of the problem we have with assessing things. It's all proprietary. There are no standards. It's a total mess. So it's not because I'm incompetent. It's because the commercial companies have deliberately made it difficult to exchange information, right? And I'll now start the thing, and I'll run for 20 minutes and then stop and answer questions, right? So what we have, I can't point to this, is we have this project. I don't know whether Simon Hodson or Francis Crawley is listening from Codata, but this is we're starting a project with them to make scientific knowledge accessible to all by making it frictionless, right? And we will have to carry out a process of disenshittification to make the material readable. Okay, next slide. Right, these are the wonderful people who are doing it. Next slide. This is enshittification, which Cory Doctorow came up with 2 or 3 years ago, how commercial platforms bugger up everything, right? And we have to disenshittify the scientific literature. Next slide. Okay, so what we need is frictionless access to all the material with semantic structure, computable components, and semantic vocabulary. And we've got to build all of that without any help from any of the companies involved who will try and make it as difficult as possible for us to do that. But I'm sure with the help of Codata and the international scientific unions, we've got a chance of doing that. So we're really starting from scratch, taking shit and turning it into something useful. Next slide, please. Okay, so the most important thing is our community here. And this is the semantic climate community. And you can see my t-shirt. Here's my t-shirt, Semantic Climate, there, which we're all very proud of. And this is our mascot, Amy, who we're also very proud of, Kangaroo. And we're going to have a help from Chuff, who is the OKF mascot, Open Knowledge Foundation, and I hope that Renato Avila from OKF is listening in, but we are working together with Open Knowledge Foundation to make that work. Okay, next slide, please. Right, so the amount of research we see published is enormous. humans can't manage it. There's much too much, and it's enshittified, and LLMs aren't 100% reliable. They're particularly bad on numbers, dates, and names, so they will. You can be guaranteed that they will hallucinate scientific information. So if we simply say to LLMs, please understand the scientific literature, they'll get it right 90% of the time, and 10% of the time they'll make a complete pig's ear of it, right? So we have to be responsible for it, not not the commercial companies. Next slide, please. Right. What's content? Well, here's some example of content. Text, structured text, which if it's published in PDF is a disaster. Chemistry, mathematics, maps, tables, all of that we need in semantic form, and it isn't at the moment. It's enshittified. Next slide, please. Right. The idea of frictionless comes from the Open Knowledge Foundation. They've created a toolkit so that you can pass tables around automatically, and they can be read into any piece of software without loss and so on. And we need to do that for our publications. Next slide. Well, it can be done. The International Union of Crystallography has done it. I'm proud that I've been part of this process, and for 30 years I've been working with the International Union of Crystallography and many other people to create a frictionless tool, SIF, which is able to pass crystallographic experiments between different communities. And it works. And that's because an international scientific union is doing it and not some commercial company which shittifies it. Next slide, please. However, companies don't just make terrible files, they actually throw lawyers at you. So Chris Hartgerink tried to text mine Elsevier's material, and they sent him his university a cease and desist and said, stop Chris doing his research. And first of all, the university did, but then they took Chris's side and supported him against Elsevier. I've had this happen to me, and I can't use the library at Cambridge. They said you can't text mine the subscription content because it will upset the publishers. So that's why I'm working with Gita in India, and we only use open access material. So half the literature cannot be made semantic because the publishers stop it. If the publishers wanted to collaborate with each other, then we have the tools to do it. The same thing happens in computational chemistry, where chemists in many universities were banned from using Gaussian. That's this little figure on the right. Sorry, next. Yeah, on the right. And it was called bannedbygaussian.org. So the 99% of the problem is people. 99% of the problem is vested interests, gatekeepers, and so on. And I've been trying to get past this for 20 years, and I haven't won. I hope that the international scientific unions can bring pressure to get free and frictionless movement between different organizations, types of information. So here's an example of how friction kills a table. There's no software in the world can read that table. Only humans can read it, and there's so much produced, there aren't enough humans to read it. I've been developing software which can do quite a good job of reading that sort of table into semantic form, but nobody's interested. Next slide. Here's a typical image in a phytochemical paper. There's no machine in the world that can read that caption and associate the figures with it. It's completely unnecessary to turn those figures into 8 small figures there because of the page limit, which is insisted on by the publishers. And we have to assert the right to have semantic figures rather than corrupted figures. Next slide. Right. So some of us in chemistry built a blue obelisk community where we made all of these programs interoperate. It's not complete semantic frictionless free interoperation, but it works pretty well on the whole. And that community has done a great deal to try and make chemical knowledge free. And I'm told that Nolo Boyle, who's one of them, who helps with RD Kit, said that Schrödinger has made contributions towards RD Kit. So thank you, Schrödinger. But not all computational chemistry programs do this. Next slide. Okay, so the principles were set by Richard Stallman for software. Here's Richard Stallman presenting me with a GNU. Here's the GNU, and I should introduce, we have all the animals are waiting here. So we have Open Knowledge Foundation, we have Semantic Climate, and we even have my own Jumbo for chemistry here. So all of these are solved technical problems. The problem is people. Next slide, please. So I've worked with the Open Knowledge Foundation, who've come up with the open definition. We should be able to read content, redistribute copies, extract and compute content, distribute this. We should have the complete freedom to do anything we like with published material. And that is true if you use an open license. But many publishers don't use open licenses, or they have things that look open and are not. So next slide, please. So in semantic climate, our knowledge is to create verifiable, computable climate knowledge. And we take as sources of truth the IPCC, the UNFCCC. Goodness knows what's happening to the poor United Nations this week, and so on. But we try. We want to work with them. It's not been easy. And we have 1,000 publications a week, so we've got to automate the process. So in semantic climate, which is built on volunteers rather than a seriously funded project, we're trying to create current climate reports and make them semantic. Next slide. So this is our phytochemical experiment. We've got our blue tea, purple tea, and our blue tea, and we are converting them using our lemon juice. and so on. But the main point is that all of these have got unique identifiers from Wikidata. And I don't have time to talk about Wikidata, but it's one of the most wonderful developments in the 21st century, that everything can have a unique identifier. So all of the things in this picture can have unique identifiers and have a unique vocabulary. And that's the first thing that we have in this. Okay, we've got to label everything. That's the vocabulary. Next slide, please. And then we can turn the vocabulary into knowledge graphs. And a knowledge graph is a computable system with links between the objects. Next slide. And here's what we did last year. We took the IPCC and turned it into a knowledge graph. Next slide. And there are literally thousands of ontologies in the linked open data sphere. Not many of them are used, lots of them in life science. So we can find ontologies for plants, for climate material, for diseases, for bacteria, for all sorts of things. And that's all in the linked open data that we have. But chemistry is pretty poor about it. The big players enshittify it, such as the American Chemical Society and Chemical Abstracts, who've made it extremely difficult to get semantic information. But the open community in chemistry have done a good job in trying to liberate some of this. Next slide, please. Right, so here, this is created by Philipp Strohmert from TIB in Germany, and he's shown how you can take a piece of text here and mark it up using ontologies. So if I'm lucky, this will actually work. If I go to something like Kebi. So here's Kebi. Oh, can you click on the Kebi? I can't click on it. Can you click on Kebi and see if anything exciting happens? Polytext, right? No, it doesn't. Okay. Well, that will link to the Kebi ontology, which has, hundreds of thousands of chemicals in that. So we are beginning to mark up the literature. We don't have the relations between them, but we have the link. I've done 17 minutes on my clock. Next slide, please. So we're creating an automatic workflow to make our vocabulary here, and we can read in it all sorts of information. We're doing this for climate. This is an automatic workflow to go all the way from raw material to knowledge graphs. Next slide, please. And Renaud has created these links to our encyclopedia for blue tea. So we did this yesterday. So can you click on that, please, Asmi? And that should take us through to a blue tea encyclopedia. We've got an encyclopedia for blue tea, we've got one for climate, we've got one for phytochemistry, for all sorts of things, right? Can you just open that?
Yeah, I'll have to. Yeah, 1 second. I'll have to share screen once again because it's only showing the PowerPoint right now.
Okay, well, don't worry about that. I'll finish my talk here by aiming this
There you
at,
go.
um,
You should be able to
oh,
see it
there's a
now.
data tables, right? So this is automatically created by searching the literature. Can you click on one of those? Doesn't matter which. All of these are individual papers. Um, and there it is. It clicks through. Yes, have we got, right, okay. What's the title? Right,
Oh,
very good. So there's Clitoria ternatia. This is blue Clitoria ternatia tea, certified on the packet. And that's taken me to 19 minutes. So I'm aiming this now at Francis and Simon. If they're listening to this, can the international scientific unions and CODATA try and create a framework for semantic science that we can all post into where we actually are able to use machines to assess the literature. And I'll say thanks to everybody and stop there.
Thank you, Dr. Peter, for that insightful presentation. If anybody has any questions, please write them for Dr. Peter in the chat.
Right, well, while, are you going to read them out, Asmi?
Yes, I can read them out for you for sure.
You read them out if, as soon as we got some, but before that, I'm going to ask the community, how do we make this happen? And it's a people problem. Okay. Uh, Sci-Hub is banned in India, absolutely. So this is as much a statement as a question, I think. How Sci-Hub is banned in India by Elsevier and the American Chemical Society. How do we change that? Goodness knows. I think people have to go to prison. I'm serious. The only way that we can break this, and it's true of climate knowledge and all sorts of things, is by challenging the system. One of my colleagues in Cambridge has gone to prison for trying to get climate knowledge acceptable, by the world. Next question.
Okay. Okay, I'll be reading out some questions for you. Here's one. How can we be a part of Semantic Climate? How can we work with you?
All right. Right. Individuals can join us as volunteers. We had wonderful volunteers. The software that you saw in the last slide was written by a 15-year-old school student in India, Singapore, Ayush. So anybody can join. Anyone from high school up can join. We allocate tasks which we think are appropriate, and they go off and see what they can do. So that's a simple way. If you're an organization, then please try and put some sort of human resources into making your information semantic. And this can be done in subjects. You've got to have the will to do it. So that's we can provide guidance and software, but you have to want to convert the information. Next question.
All right. The next question is, could you please brief again on what you meant by it is a people problem?
Right. Well, people have to be willing to change the world. You can't wait for me to change the world. You can't wait for ASME to change the world. You can't wait for NIPGR to change the world. You have to want to do it. And so you've got to push your scientific discipline to become semantic. Crystallographers have done it. Environmentalists have done it, but chemists have not. And chemists still publish their material in PDF and they hide it behind paywalls. And as long as that happens, it's not semantic. So you've got to go out into your community and either convince your colleagues, whether they be plant scientists or whether they be chemists or whatever, to make it semantic and to say this really matters. And in climate, you've got to try and get the information that you know about made semantic. I can't do it. I can help you do it. Next question.
All right, thank you, Dr. Peter. Due to time constraint, that is all the questions we'll be taking right now. Appreciate it. That was a beautiful presentation.